Hello, everyone. A warm welcome to this virtual training series on developing solutions for Microsoft Azure. I'm Monica from TechnoFocus, and I will be serving as your moderator today. We're glad to have Tiago Costa with us, who will be presenting today's session. He is a Microsoft certified trainer, a Microsoft MVP, and cloud architect and advisor. He is currently based in Portugal. Before we get started, let's have our housekeeping announcements for the day. If you happen to face any audio or video issues during this broadcast, please let us know through the Q&A panel. If you have any technical questions, please post your queries in the Q&A panel, and we will do our best to respond to them in real time. Please note that this training program will also be recorded, and the recording will be available for on-demand viewing approximately 48 hours after today's broadcast. Now I'd like to turn today's event over to our presenter. Tiago, you have the floor.
Hi everyone, my name is Tiago Costa. I'm an Azure MVP and Microsoft Certified Trainer, and I would like to welcome everyone to Day 3 of Developing Solutions for Microsoft Azure. So, on Day 1, I had the pleasure to speak with you about how to create virtual machines, managing virtual machines, and then we talk about container technology and how to run containers, how to store container images in container registries, all of this, of course, in Azure. On Day 2, we talk about storage, we talk about SQL databases, we talk about Cosmos DB. Today is a day that we're going to talk about how to implement Azure App Service solutions. So we're going to talk about Azure Web Apps, Logic Apps, functions, and API management. And then we still have 2 more days where we're going to talk about how to implement user authentication and authorization. So an Azure AD module. Then we're going to talk about security and how to secure Azure storage solutions, and also about Azure Key Vault and how can Azure Key Vault help us make Azure secure. We still have Day 5 where we're going to talk about monitoring, optimization, and message based solutions. So we're going to talk about instrumenting solutions to support monitoring and logging, integrating caching, so we're going to talk about basically Redis cache, and also event-based solutions, and of course then developing for message-based solutions. But let's get started and let's talk about implementing Azure App Services solutions. Like I said, so first we need to talk about the Azure App Service web apps, and well, before we even start to deploy here web applications in Azure, let's talk about the Azure App Service. So the Azure App Service, it's an HTTP-based service that it is totally managed by Microsoft. So it's a managed web server that I can use to host web applications, REST APIs, mobile backends, and all this, and I can develop, and I can still develop, okay, in my favorite languages, like, I'm a .NET Core developer, for example, myself, so I prefer to use .NET Core. But then, of course, I have customers that they have applications that they are created in Java or Ruby or Node or PHP or Python. And, well, all of those applications can still run, of course, in the Azure App Service web apps. So there is no limitation on the technology about this, just not run only Microsoft technologies and platforms. No, this can run all the major platforms and technologies. Then, of course, a great thing that I have is that I can run those applications in just one instance. Or I can also say, hey, no, I want to configure scaling, and more precisely, I want to configure auto-scaling because I want this to scale automatically based on metrics. I need to have an integrated load balancer, and I want all of this to work seamlessly, so without any user or administration effort. And yes, we can make that happen because, again, this is a managed service. And all of this, underlying the scenes, all those instances, they can be based both on Windows or Linux. So they can be Windows or Linux-based environments. So again, we know some of these languages, well, they will work better in one technologies than the other. So just choose the technology where your workload will work better. So you don't need to choose one or just the other. No, you have the choice and you have the power of the choice. Also, the app service not only adds the power of Microsoft Azure to your applications, such as security, load balancing, and auto-scaling, like I already talked about, but you can also take advantage of the DevOps capabilities that this service has, like continuous deployment from Azure DevOps, GitHub, Docker Hub, and even other sources or package management and staging environments. So all of those will be possible. Also, I have features like custom domains, like setting up a custom domain in an Azure web app. It is really easy. It's just like 5 minutes, and you have your web app fully protected with a custom domain and a TLS SSL certificate. So with App Service, I will pay for the Azure compute resources that I use. So imagine that I have a web application that was running in 2 instances for 2 weeks, but then in 1 day we had to grow to 4 instances because we got more load. After that, it just decreased again for 2 instances. We just have like a peak there during 1 day. Let's just say during 24 hours in a row. So only that day is that, yes, you're going to pay 4 instances, but all the other days, you're just going to have just 2 instances. And of course, you're going to pay for those 2 instances. But this is the advantage that we have. Also, if you have several web applications, so what we pay here is an app service plan. This is the layer that we're going to have, that will have how many instances do I have. But now inside that app service plan, I can have several web applications, and I'm not going to pay more money because of that. I'll just pay the amount of money for the app service plan and not for the web apps. So understanding Azure Web App Service, so I can create this using the Azure portal. I can just go there and just create this. And of course, then the app service will have features like deployment slots. So deployment slots is an awesome feature because I can create in the same web application a different environment. And for this, I will create, imagine, a development slot. And then we publish for that slot. And after a while, I can just say, oh, okay, so I just push some code there. I'm happy with my code. I can easily swap from that development deployment slot into the production slot. Or, of course, maybe something in between, okay? And this is just like a click, okay, in the Azure portal, and it will just do the swap. It is, again, very easy to do this. I also have continuous integration and deployment support. So the Azure portal provides out of the box to that deployment center that you can see there on the picture, easy integration with Azure repos, GitHub, Bitbucket, local Git repositories, or even through FTP. Not that recommended today, but yeah, we can still do this. I can also integrate this very easily with Visual Studio. So Visual Studio can download the publishing profile, and it can automatically publish a web application. So it is, again, very easy to do this. You just open Visual Studio, right-click on the project, click Publish, and then you have a wizard to select your web application, and then it's just clicking on a button, say Publish, and then after, well, some time, depending on the size of your web application, of course, usually a couple of minutes is more than enough, you have your web application deployed on Azure. Now, I personally don't recommend that in production scenarios. In the enterprise market, you do this. Usually it's better for developers to publish for a Git repository, and then from that Git repository, like imagine Azure repo, and then from there you can configure, like for example, Azure pipelines or Jenkins, something like that, that then, yes, it will do the publishing of your application. Like I said before, we have built-in auto-scale support. different operating systems. So after I select the stack that I want to deploy, I can then choose if I want this in Windows or in Linux. There's some limitations because, well, some stacks don't run in one or the other operating system. Like if you have .NET Core will run both on Windows or Linux, no problem. You can choose one or the other, also in the app services. But if you go for .NET, for example, it's different. Okay, like .NET 4.7, 4.8, it basically will be different. It will only be available for Windows. So you have that limitation. But this is a limitation on the framework itself. It's not an app service limitation, of course. So time to start and just do a demo. Let's do a demo on how to create a web application just using the Azure portal. Okay, so it's time to create a web application using the Azure portal. So I'll just go to create a resource and I will just search for WebApp. I will just select this. I will click create. And now I need to choose the subscription. What is the resource group? And because I still don't have a resource group, I'll just create one here called AZ Videos, for example. And then I need to select your name for my web app. This name needs to be globally unique because it's a subdomain from the Azure Websites.net domain. So it needs to be totally unique in the internet. Then I can choose if I want to publish code or a Docker container. In my case, I'm going to say I want to publish code. The next question is about the runtime stack. So I can choose .NET Core 3.1, for example. Of course, you could always go to Java, ASP 4.8, Node.js. You still also have PHP, Python, and even Ruby. But in my case, I'm just going for .NET Core. And then I can choose if I want Windows or Linux as the operating system. So I can just choose one of this. And then the region where I want to deploy this. I can just choose here, for example, East US, if I want to choose a different region than the one that was defaulting here. And then the last bit here is around the app service plan. So this is the web app, but now what I have done, and now I need to choose this bit here, which is regarding the app service plan. This is basically what we pay. I need to give here a name, and I'm just going to call this app service plan AZ Videos. This is going to be the name. I just want to have like a proper name and not the suggested name by the Azure portal. And then I can click where it says change the size, and then I can see all the possible sizes that I have regarding the app service plan. So I can see here dev and test. I have here free. I can do for a shared one. I can go for the basic and even click here, and in the basic you have 3 sizes. So feature wise, all B1, B2 and B3 are the same, but just the size of the underlying virtual machine, that is different. So the first one, you have 1 CPU, 175 gigs of RAM, and then you're going to have 2 or 4 CPUs, 3.5 gigs of RAM or 7 gigs of RAM. If I go to production, it's kind of the same thing. So you get more features. We start to get like features like autoscaling, like staging slots, so things like this. And you see here, I have really a lot. So I have standard and I have premium. And premium, I have premium V1, V2, and V3. And each one of them has 3 sizes. So as you can see, yeah, there's a lot of sizes here to choose from. So it's basically something that you can fit a lot of businesses. So in my case, because this is just a demo, I can even go to the free one. I don't even need to pay for this. The next step, it's about monitoring. So if I want, I can right away create also an application inside instance, and then I'll go, of course, also get basically monitoring and telemetry data about my application. Because this is just a demo, and we just want to see the web app ready up and go, I will just say no here. But enabling application insights, it is really interesting because you're going to get a lot of good insights about your web application. Then the traditional tags, again, because this is just a video for a demonstration, I'm not going to put tags, but I will call for it. It is really important to tag your resources. Under the review and create, so it will just pass, everything is good, and I'll just click create, and now I'm creating my web app. And creating a web app doesn't take that long. It is very fast to create. Usually just takes a couple of seconds and then it is done. So let's just wait a little bit here to see this in action. Here you go. So if I now go to the resource, so you can see here my web application is up and ready. If I click browse, okay, you can see here my web application is just loading, and there you go. Okay, so, and if we just take this out of the full screen, we can see here, so this is the URL that I have, so azvideos.azurewebsites.net, and this is the landing page for the app service. Okay, now, yes, now I need to deploy that, but we're going to do that in a further demo, so just wait for it. So now let's talk about understanding diagnostic logging. So first of all, what are application logs? Application logs basically are the output of runtime trace statements that we have from our application. For example, I might want to check some logic in my code by adding a trace to show when a particular function is being processed. I might only want to see a logged message when a particular level of an error has occurred, stuff like this. So application logging is basically the primary for apps or in pre-production and for troubleshooting issues. If you do excessive logging, well, that's never a good idea because it can carry performance hit that you might don't want to have, and also you can basically very quickly consume a lot of storage. So application logging has, of course, scale limitations, primarily because files are being used to save the logged output. If you have multiple instances of an app and the same storage is used to share across all the instances, messages from different instances, they might be interleaved, making troubleshooting hard. If each instance has its own log file, there will be multiple logs, again, making it difficult to troubleshoot instance-specific issues, okay? So types of logs available through the Azure App Service depends on the code framework or the application, or if the web app is running on a Linux or on a Windows host. So, but let's get started with ASP.NET for Windows applications. So ASP.NET apps that they are only running, okay, on Windows, and they use the system.diagnostics.trace class to log information. If we're talking about ASP.NET Core apps, they already run either on Windows or Linux, and to log information to Azure application logs, I need to use the logger factory class, and then use one of the 6 levels of logging that I have, like log critical, log error, warning, information debug, or trace. Also, if you talk about, for example, Node.js applications, so those script-based web applications like Node, they can run on Windows or Linux, and they are basically logging is enabled by using the console method. So you can just say console.error, and then you just pass a string, and that message is going to be written to the error message. If you just do console.log, it just writes the message to the std out, and those are the level logs that I have for Node.js. So if we do like a kind of a resume, so we get something like this, that we're talking about ASP only for Windows, I can save them on the file system or on a blob storage account. If you're talking about ASP.NET Core for Windows, I get the same log levels, and I can save them also for file system and for blob. If you're talking about Linux, only file system is the saved location that is possible to have. And if we're talking about Node.js, again, on Windows, I can have file system and blob. And if I go for Linux, only for the file system. Okay, so basically those are kind of the limitations. But better than explaining what I can do, let's do a demo. And let's do a demo on how can we enable and configure, okay, app service application logging by using the Azure portal. Okay, so now it's time to create a web app and then configure monitoring on that web application. So we're here in the Azure portal, and yeah, I could just create things by clicking a web application, and I also will need to have a storage account where to store my logs. But I can also do this in a different way. So in this case, I'm going to use Bash in order to do this. So this first bit here is just creating a series of variables with a Git repo, a name for my application, a name for my application service plan, also a location for my resources, and then resource group name, and then a name for my storage account. After this, I'll just do this AZ group create that will create my resource group. And after my resource group is created, I'm going to create an app service plan. So line 13 is to create that app service plan. And after that, I'm just going to create a web application. So I'm now creating the web app. The app service plan was already created. And after this, the creation of the web app, it's also going to deploy, because you see the last bit of line 14 is deployment source URL, which is that Git repository that I have as a variable in line 1. And so that application, it's going to be deployed to this web application. So let's just wait a few seconds for this to finish. So there you go, it is done. And after the creation of the web application and deploying a web application there, I'm also going to create a storage account. So this storage account is to store all my logs that the web application will produce. So now let's just wait here a second for my web application. So for my storage account to be created, and there you go, it is done. So after this, I'll just go to the Azure portal. And if we go to resource groups, we should have here AZ training web app. And yes, there you go. We can see here the app service plan. We can see here the web application. If we refresh this, usually the Azure portal, sometimes it takes a little bit of time to show here resources that we had created, but there you go. So now we have here our storage account. So now that we are sure that all our resources are here, I'm just going to my web application. And of course, look, I could browse my web application just to make sure that, okay, yes, it is deployed here. So we just need to wait a second. It's a cold start, so it always takes a little bit of extra time. But it should be shown in Node. And there you go. So I can just go to about, contact, etc. So all is good in here. So now that we're sure that we have a web application, we can scroll down, and under monitor, we can find something called app service logs. And in here, I can define, oh yes, I want application logging, web server logging, detail error messages, etc. But let's just say that I want application on the file system on the error level, but then on a storage cloud, so on blob storage, I want, let's just say, verbose. And now I need to select here which storage account I want for this. And in my case, yes, this is going to be this SA Contoso Fashions and then the number. I can just, for example, create here a new container. So I need a container for this. I'll just call it App Service Plan Logs. I'll just create this, and then yeah, I can just select this container. And then I just need to put here, okay, what is the retention period in days for this? Let's just say 5 days, and you just press save. And basically that's it. So we have just created a web application, deployed that, and we had configured logging on that web application. So now this will start to collect logs, and in no time those logs will just show up on that Azure storage account. So how can I deploy code to a web application? So Visual Studio 2019, it's a great IDE. It's unquestionable one of the best IDEs in the market. And it has a super tight integration with Microsoft Azure. There's a lot of resources that I can connect from Visual Studio. And of course, one of them will be the app service. So I can easily access monitoring data, telemetry data from an Azure web application. But in order to deploy imagine a ASP.NET Core application into the app service, I need to make sure that I have the proper Visual Studio workloads installed. So you need to make sure that you have the ASP.NET and web development workload and the Azure development workload. If you have those two, you will have all the components that are needed to create a web application that can then be published directly from Visual Studio 2019 into Azure. And that's the beautiful part of all of this, is that basically I, as a developer, don't need to leave the application where I live, which is Visual Studio. So you don't need to leave Visual Studio in order to deploy your application. You just need to make sure that you have the proper workloads installed on your machine. So let's just jump here and let's just do a series of demos, where the first demo, it's going to be, let's create a new ASP.NET Core web application. Then taking that ASP.NET Core web application, I'm going to deploy that application to Azure. And later on, I can even tweak, okay, the app settings of that application, and you will see this reflected immediately on the output of your application, on the behavior of your web application. Okay, so now let's create here a project under Visual Studio. So I'll just say that I want to create here a new project, and this will just load here. I'll just select here ASP.NET Core Web Applications, and I'll just press Next. Then I just need to provide a name for this. I'll just call this Alpine Ski House. I choose a location for this. This is a great location, and I'll just click Create. When we click Create, so we have the option, yeah, .NET Core, ASP.NET Core 3.1. That's what I want. You could choose other if you still if you want it, but 3.1 for me is great. So web application, and I'll just click Create. So now we are just going to wait for a second for this to create our project. So Visual Studio is just loading our project, and it should load in no time, and there you go. So now that we have loaded Visual Studio and we have our project here, I can just click IIS Express and can just say, hey, let's just try to see this in the local system, so that we are sure that our web application is up and running. So let's just wait here a second, and there you go. So usually like this is always like a cold start, so usually takes a few extra seconds, which should be normal. So don't find it weird if you're trying to replicate them on your side too. So there you go. So we have here localhost 44343. I can just privacy home, and yeah, this is the web application that we had built. Of course, this should be a proper web application, but the advantage that we have now with the integration with Azure is that I can just right click here where it says Alpine Ski House, and I can click publish. And because, well, Visual Studio is so well integrated with Azure, we get a bunch of targets here that for me to publish. And of course, I can publish to an IIS, import a profile, an FTP to the local system, which are the traditional ones that we already have in Visual Studio for many, many years. But I can also say, hey, I want to publish this to Azure or even to a Docker container registry. So in my case, okay, I'm just going to say Azure, and now it's going to ask me like, oh, okay, yeah, I'm going to drop this in Azure, but what do you prefer? It's an Azure App Service, Windows or Linux, or it's a container registry, or even an Azure virtual machine. So we're talking about Azure App Service. In my case, I want to deploy this to a Windows App Service. I'll just press next. And now this will just connect with my account. And the advantage now is that I can just click here, just select my subscription where I have my web application. I have this AZ Videos, and I find this AZ Videos web application that we first created, and I can just click finish. When we did this, what happened in the back was that it downloaded all the publishing profiles, so all the settings in order for me to be able to publish. Did it publish? No. To publish, you still need to click here under publish. So this was just the first phase, which is basically just downloading the publishing profile that has the settings. And now this is going to be publishing the web application, and when it finishes, it will just open that Azure web app, and you're going to see that, yeah, this is just going to show exactly the same page as we had on-prem, but now it is working on Azure, and you can see here, so we see it over there, so azvideos.azure website.net, and it's our Alpine Ski House application that it is here, and it has been deployed successfully. If we go now to the Azure portal, and if we try to go to resource groups and then AZ Videos, and now I choose my web application that I have here. So we can also see there here under configurations, I can basically define several configurations. So I don't have access to the web server. Yes, that is true. You don't have access to that. But I can go here, I can come here, I can just look, create application settings. They are encrypted at rest, so they are secure. I can go to general settings, and this is the .NET stack. Yeah, it is. It's the .NET Core web application. But if you wanted to create another kind of application, you can just switch here to Python, PHP, or standard .NET, Java, you name it. And we have here also like, or what's the version of HTTP. If you want to do this, already supports HTTP 2, and you can define that there. And then, of course, look, if you want to do remote debugging, yes, I can do remote debugging, and then you just define here, hey, I want to activate remote debugging for 2019. Of course, look, it's not very safe to do in production, but hey, if you have like a development environment, etc., why not? Okay, that's why we have this available here. Default documents also say define here what are the default documents of the entry points for your applications. Path mappings, the same thing. I can create handlers in here. So all of this, it's in here at literally one click away, and you can just do this. But focusing here on application settings or connection strings, what you define here, be careful with this, will override what you have on an app config or a web.config file on your web application. Okay, so what we define here will override what our developers wrote in their application. If, of course, look, we create a connection string with the same name but a different value. So this is great because I can override their values and I can just point, imagine, to a production database and not to a database that we created, like a sample database for the development team to have this. So yeah, we can do this kind of stuff. So it is pretty cool. One last thing here that is important, one last point. When you press save, because you did some changes, this will do a recycle on the application pool. So you might find that your application will have a tiny downtime because of that. So doing this kind of changes during peak hours, probably it is not a very good idea. So you should try to do this kind of stuff in non-peak hours. But this is it. So this is how we can go to Visual Studio, deploy an application, and see here some of the settings under the configuration page. So when it comes to scaling a web application, well, first of all, I can do manual scaling, which is I just need to go to my app service and I just need to say how many instances do I need for autoscaling, for scaling. I need 2 instances. You just go there, save, and you have 2 instances. Oh, I need 5 instances, and you just need to go and you can do this in a portal. You can do this via PowerShell, Bash, you name it. Just go there, just say, I want 4, 5, 10 instances. And, well, you just get it. As you can imagine, even if this is easy to do, I want to scale based on real-time demand and load that I'm having on my web application. So with this, what I mean is, if I get more traffic, more load on my application, I want to have more capacity in order to respond to that load. So this is where enters a great concept, which is auto-scaling. So auto-scaling, what I will do is I will just monitoring a metric. And let's imagine we look at our web application and we consider that our web application, a good metric to measure will be CPU. Because look, it doesn't need to be CPU because we could put auto-scaling rules with disk I/O, with memory usage. So all of those will be great metrics that I can also use. But you need to see in the workload that you're having, so your web application that will behave differently than my web application for sure, what is being spent first. And like, look, I first run out CPU, then I run out memory or disk I/O or other metrics. So okay, if I run out this first, yeah, that's the metric that I want in order to scale. And then we decide that, well, I need to create rules. And for this, we have 2 rules that I need to create, which is basically the scale out. So I will just say that, hey, if I have the CPU usage higher than, let's just imagine 70%, I want to get 1 more instance. But I also need to create, and you should also create a scaling. And when we're talking about a scaling rule, we're talking about if I don't have load now, I can start to remove some of those instances. And of course, I will also save Azure credits by doing that. So what I will do is I'll just have a rule for scaling, like saying stuff like, hey, if I get less than, I don't know, 35% of usage, hey, and that means that I can have 1 less instance. All this and all these rules, you can also then say that I have a minimal number of instances and I have a maximal number of instances, so that you don't grow more than the number that you define as a max, because sometimes you might get some budget considerations with this, that even though like premium can scale up to 30 instances, you might say that, hey, look, I have a budget limitation that says that, hey, yeah, I can only go to 5 instances. So let's just put that on the max. But then on the minimal, look, I will always like to have 2 instances so that I can have a more highly available. Even though we know that there's no higher SLA, just because you have two instances. Because if you have one instance or two, the SLA for app services will always be the same. But nevertheless, well, I need to have two. I prefer to have two in order to have a highly available web application. So I can do this, and I can do this based on metrics. You can also say, and this based on metrics, it is great for what? It is great for unpredictable growth. So I was not predicting this growth. Okay, this rule is awesome for doing that. But I can also scale based on the schedule. And when you do based on a schedule, it's usually because of a predictable load. You know in advance that you're going to need X number of instances for that application. And that's great, because imagine the case. I know like Friday night and Saturday night, my web application will always need to have a higher number of instances. I know that I will never always need to have, let's just say, 6 instances. So just create a schedule rule. Don't wait for the load to come for you to grow. And then if you still need more, if you have like 6, but still get more and more load, and that day you even are getting more load than usual, so you know that I need 7, 8, 9 instances. Well, the auto scaling rule will kick in, and it will do the grow up to the limit that we might have defined, if we had defined a maximum number of instances. So, but let's just do a demo, and I'll just do a demo where I can scale a web app, and you're going to see how can I scale a web app manually, but I'm also going to explain how can we create auto scaling rule for this. Okay, so taking the web application that we just used before, so I'll just go here to resource groups, AZ videos, and we can find here our AZ videos. So I will try to do manual scaling and also auto scaling. But to start, I need to go to scale up under settings, and I need to switch this from the free tier where I am at least to a standard one, because the standard one, it's the first one here that you see here that can give me auto scaling features. So I'm just going to switch this now to, and I'm going to update the plan to standard plan, so that I can get to do manual scaling and also to be able to do the auto scale. So that part, it is done. So in order to do horizontal scaling, I need to do the scale out, and then in scale out, so you can see here, manual scaling is really simple. How many instances do you want? You can switch this up to 10, because this is a standard. If I went to like a premium, you can go up to 30. If you're talking about the isolated plan, you can go up to 100. So I have done this, and I just need to save. And basically that's it. So if you do this, and if we scroll up and we go to the overview blade, you will see that in no time this will show up here, and you can already see this in here. So the app service plan, it's an S1 standard one with two instances. So there you go. It is already done. And this is manual scaling. It is literally just this. It is really easy to do. What about if I go again here to scale out? But look, I don't want to do a manual scaling, because sometimes I have unpredictable loads, and I really want to have this done automatically. Okay, so we can also do that. I can go to custom auto scaling. We need to give here a proper name to this. So I'll just say ASP videos auto scale rules, and then in that resource group, that is great. And now in here I can just say that, well, I will have a rule And what is going to be my role? So I'm just going to stick with the default, which is the metric will be CPU. But if you click here, you can see you have a lot of other options that you can use in order to say I will grow to I will just have more instances because that specific metric has reached a certain threshold that I defined it. For me, and most applications, CPU is kind of the default here. So I'm going for that, and I'm going to for 70%. So that means that when the overall instances, the CPU percentage is 70% or higher, basically what I'm going to do is I have this action, okay, option down here, and the action says I will increase the number of instances, okay, by 1 with a cooldown period of 5 minutes. So that means that this will not run again in 5 minutes because we need to, well, cool down the existing instances with the new one that basically was created. The operation, you can say different things. You can say increase the count or increasing the percentage or increase the count to a specific number. So for me, increase the count by usually works very well when you have small environments. But of course, when you have big environments, probably you want to do a percentage because just growing one instance when you have 30, 35, 40 instances probably is not going to do that much. So maybe you can say, hey, I want to increase the percentage by 5, 10%, which means growing like 2, 3, 4, 5 instances at once. And that, okay, yeah, that will make the difference for your workload. So I'll just go here, I'll just click add, and this is my scale out rule. Of course, if I don't have demand or if I have less demand, I also want to do just the opposite, which is I want to reduce the number of instances that I have, because if I don't need them, I'm not going to pay for them. So of course you can do that too. So you will add here a rule, and now still CPU percentage, all of this, but now here instead of if the metric is greater than, no, it's going to be less than, and let's just say 35%. I'm not going to increase the count by 1, but I'm going to decrease the count by 1. So basically I just did kind of the opposite rule. And then, yeah, so now this, yeah, it's going to get more instances, so scale out, and also going to reduce the number of instances or scaling the app service plan. Still, I can play around here with the instance limits. So I can just say, hey, look, I want at least to have 2. Okay, and we'll just put the default also to 2. And the max, we know that, well, standard can go up to 10. But let's imagine that I just want to go the most to 5 because we have some budget considerations to take into account. And we cannot afford with our budget more than 5. So this is basically a rule and a scale condition to grow automatically. But sometimes still you know that, imagine Friday night and Saturday night, you always need to have at least like 4 instances because, well, you know, we have a bunch of load, etc., and it's predictable. So I don't need to wait for the load to get to the application and then this rule to kick in. No, I just want to say that after a certain hour, hey, look, just get 4 instances and that's it. Okay, we can click here where it says add a skill condition, and I now say not on a metric but on a specific instance count, and we define 4. And then I need to say, well, repeat specific days because it's every Friday and every Saturday. So I remove the Monday, Friday, Saturday, they are activated. And then in here, I just say, well, starting at, let's imagine 5 o'clock and it ends at 11 p.m. So yeah, we can just do this and that's it. Okay, now we have a rule that defines that every Friday or Saturday night, yeah, this is how it's going to behave. I'm going to have 4 instances. And now, look, I just need to press save. And there you go. So now my configurations are being saved into my app service. And this is how simple it is to define this. So there you go. We have created some scaling rules in our application. Okay, so now it's time to talk about developing app service logic apps. And we talk about what is a logic app. So logic app, it's a service that we have on Azure that will be able to automate the execution of business processes. So a business process, or also known as a workflow, it's a sequence of tasks to produce a specific outcome. The result might be a decision, data, notification. We can do like what we see here on the picture. It can have a new tweet that has been done on Twitter about my product or service. I will detect that, then I will send this to, for example, cognitive services. On Azure, it will detect the sentiment of that tweet, if it's a neutral, positive, or negative. And then based on that, I will make a decision. So I will have like a control there. Is the content positive, yes or no? If it is yes, just store it on a database so that we might use it later for some machine learning or something like that. Or if it's no, if it's a negative, if it's negative, maybe we should send this to some kind of customer service application in order to take care of that negative, basically, tweet. So maybe interact with the user that has done that in order to understand why he's doing a negative tweet about our product or service. And so when we can do this in a very graphical way, so we have a designer that is called a logic app designer, where we can arrange this in boxes, and then we can drag and drop those boxes, connect them. So it's a very UI experience and a very no-code experience. So basically, logic apps allows us to automate this using the graphical tool. We have components, and those components that we're going to have will allow us to get to hundreds, if not even near probably thousands of SaaS services that are available today in the market, and very known names, and also, of course, a bunch of Azure services. The power that we have with logic apps comes from the diversity of those built-in components that we have, and then put them all together. I can get for example, a SaaS service that has to do something with file storage. Does someone drop a file there, and then I will take that file and I will read that and just create a purchase order on our SQL Server system. But this is the kind of stuff that we can do. If you see that you have like a custom application, and you also want to create and integrate that with logic apps, and you have people doing and creating logic apps that they are not developers, so you can have a development team create those components and deploy those components, and now they have them there, so they can drag and drop and use them like all the built-in ones. There is extensibility also on this. And of course, I will also like to describe, sometimes people, can you just describe logic apps in just one word? Yeah, for sure. I will just say integration, because logic apps helps you join a bunch of different services that are so different and implemented as a workflow. So it is really, really cool what we can do with this. So, but how do we start? So we start to create and use connectors. A connector is basically a component that provides an interface to an external service. So it can go to Office 365 Outlook, for example, to read or to send emails. So all of this, it is possible. And of course, like I said, you can build your own custom connectors. If I have a service, and of course, it's a very custom service, I just build it just for my application, just for my company. So of course I don't have this in the provided built-in connectors. So, but you can also build your own, and you can build and create a custom connector. You just need to generate an OpenID or Postman description of the API, and then it's really easy, okay, just to build this in and then just use it. Those connectors, they come with triggers and with actions. So when you drag a connector, then you can just say, okay, this will be a trigger. And like you see there on the left, on the picture more on the left, we have Twitter. And the same example that we had before. So we need to have what? We need to have a trigger that is to start our logic app. And the trigger will be, oh, a new tweet has been made about our product. So we need to connect to Twitter and detect that. And after we detect that, yeah, we can just keep and just do the next steps of our process, of our business process over there. And then, of course, we can have actions, detect the sentiment. So I get some of the data that the previous trigger detected, and it just, that data just flows to the next action. And then, yeah, I'll just call, for example, Azure Cognitive Services to detect the sentiment. And then I can have a control over there that will make the decision between if I call one action or the other action. So the action to store the link in a database, or the action to email the customer service. When we have a component, that component can have triggers and actions, or just triggers, or even just actions. Some of them don't have triggers due to the nature of the service, or well, sometimes because they were not developed. Those features are still not there yet. And this gets a very interesting point, is that sometimes we get new features into connectors, and from time to time, so I always say to people, hey, just keep up with the documentation of this, because yeah, sometimes Microsoft just adds a new action on the component, or you just get a trigger and you never had a trigger on this. So they are always updating this. Talking about the control action, so here I have a control, so that is positive. So I could just do that. I can have conditional statements. I can have switch. I can have for each, until loops, and then I have unconditional branch instructions. So all of those are possible to have there, so that we can basically detect over there if I need to go to one part or not. So that will be a conditional statement over there. So sometimes people tell me when should I use logic apps? Because there's also a big discussion in the community about logic apps versus Azure functions, because in Azure functions, we're going to talk about them in just a moment. In both of them, we have triggers, and we can then also do things, and we can also do business processes in all of them. So yeah, look, for sure, logic apps are great and Azure functions are great, but logic apps are more target at the non-developers. But me as a developer, I can say that, well, I really sometimes I just need to write a small business process, and yeah, this just works. Why should I lose, I don't know, full day coding something when I can just in a couple of hours just drag some stuff here and then just use this? And so it's also sometimes the flexibility that will make me the decision to go to one or the other. Performance is also a great consideration here. So Logic Apps execution engine scales your apps automatically. So Logic Apps can process large data sets in parallel and let you achieve high throughput. So this is, again, it's just not for small things like some people say. Oh, no, it's small things, so you can use Logic Apps. If it's large, we can't. No, you can, okay? So you can. But however, look, they don't guarantee super fast activation or enforcing real-time constraints on execution time. So if you have the needs to low sub-second response times, etc., well, okay, maybe Logic Apps are not exactly the product that you're looking for. And of course, also the connectors, okay? So that consideration is, are they already pre-built for the services that you need to access. Oh, they're not. Can you develop them using the REST or get to them using REST SOAP APIs? Or maybe not. Well, yeah, maybe you can just use something else and not logic apps. But if you can, so it's not because there is no connector that, oh no, I can't use this. No, you can. You just need to develop and code a little bit with logic. So with this, we have here a demo. So we're going to talk about calling a custom connector from a logic apps workflow. Then we're going to deploy a basic logic apps workflow using ARM templates, and then we're just going to export that ARM template. So let's just start our demo. Okay, so let's create here a logic app. So I'll just going to create a resource, and I'll just type logic app, and I'll just click create. I'm just going to select my AZ videos here as the resource group, and I'm just going to give here basically a name for my logic app. Okay, so AZ videos logic app. I'll just going to review and create, and I'm just going to click create. So now that I have done this, let's just wait for this to create. Usually logic apps are really fast. There you go. So just like 2-3 seconds and bam, we have a logic app. So now that I have my logic app, this is the logic app designer. It's the first time, so I can start with a common trigger. I have even built in already templates here that I can just reuse. In my case, I'm just going to use this. When a new HTTP request is received, I'm going to basically just tweak this here, and I want the method and I want the relative path. The method, I'm just going to say get, and I'm just going to type here the relative path. And okay, so let's just save this. And now that we have a basic logic app, let me add a custom connector so that we can call our first customer. We're going to talk about something called print framework API from our workflow. So I'm just going to home now, and I'm just going to create a resource, and in here I will just type logic apps custom connector, and I'm just going to create here, okay, a custom connector. And let me just select here the AZ videos. Let's just say printer framework connector. And yeah, I'll just go also for East US, review and create. And I'm just going to click create now into this. Let's just wait for this to finish. And then we're going, there you go. So now let's go to my resource. There you go. This is my printer framework connector. And now, so let's just edit our connector. And in our connector, we just need to import the JSON file that I have here. And I can then type here in the description something like, okay, like obtain an estimation for a picture frame. And then I just need to type, okay, what is the host name, that I have the host name right here. Okay. And basically that's it. Now under security, yeah, no authentication is great. Then we go to definition, and now under definition, well, we just need to update here the connector. So our connector has been successfully saved. So now we're going back, okay, to the logic app. Now let's just go back here to our logic app. I will click edit, and now under, okay, the next step, I'm just going to add my custom connector. In order to do that, I just need to click here under custom, and our printer frame connector will just show up. So right now I just need to go to the actions and select this get query. Okay, and this will now I'm be able, okay, to configure my basically here my get queries. I just need to put here the height that comes from the HTTP request that I earlier am doing. And after I did this, so right now I'm already calling my custom connect. After I do this, well, let me just basically create here, like for example, a response. Okay, so I will just type here response. Let me try to find, this is a built-in one. Okay, so I can just define here a response. And in my response, yeah, 200, it is fine. And in the body, I can say something like the approximate cost is, and then in here, I can just say the body. So basically what comes from that get query. So this comes from that query, okay? And so, and now basically I just need to save this. So let's see. It went and it just saved successfully. So just now I just need to basically to test my logic app. So in order to test my logic app, what I need to do is, let me just go here and let me just copy this, and I will just open, okay, a new window here. And what I'm just going to do is I'm just going to replace the height and the width here, okay, with some values. And now I'm basically just going to start my basically my workflow, as you can see. So I got the response. There you go. The approximate cost is, and then you have there the value. And of course, my logic app has successfully run to give me that response. This is, you see how easy it is just to create a custom connector. So custom connectors are not a big hard thing to do. If you can just do a REST call to your services, it is quite easy and quite accessible to create something like this. And now that we have done the custom connector, etc., I can now just go here to code view. So you can see here all the JSON of your ARM file. So if you want, look, we can just copy this, and now we can save all of this in the JSON file, and you have all the source code that then you can add this to an ARM template in order to redeploy this this logic app. So it is as easy as this. So the designer, what he creates is basically this view. So I'll return to the designer if you wish to. So it is, again, also not that hard to do this kind of stuff. So now let's talk about implementing Azure functions. And to start, we need to talk about what are Azure functions. And Azure functions is a serverless application platform that allows developers, in order to host business logic that I can then execute, and I don't need to provision any infrastructure, okay, to make this this a reality. So again, also that's always nice because I don't have to worry about managing structure, managing scaling, so all of that. It's not something that I need to worry about. I can write my function code in the language of my choice. Well, includes C#, F#, JavaScript, Python, PowerShell, Core, Bash. So all of them are supported by Azure Functions. And of course, look, I can also support package managers like NPM, like NuGet. So you can always use popular libraries within your business logic. Deciding if serverless computing is right for your business needs. So I talked about serverless in the previous slide, but I didn't went deep on that on purpose because I just wanted to talk about that in here. Serverless, it is, in my opinion, a great revolution that we have when we're using cloud services, because we can use infrastructure as service, right? And I have a virtual machine. I start my virtual machine and I'm paying for the size that I chose. Yes, we can decrease the size, put other sizes, or create more or less virtual machines, but that's what we have. We always have to have like a minimal viable system up and running, even if you don't have big number of requests and a big load into that. But with serverless, well, that changes a lot, because with serverless, I just need to focus on creating my code, deploy that code, and I don't need to do any over allocation of the infrastructure. This is event driven, so it will start when it needs to start. So what about if you don't get any requests during, let's just say, 4 hours? Well, if you don't get any requests, you don't pay anything. There is no compute charges to be made. And that's great. So in terms of having a pattern that really matches the consumption based to what I will pay, this is perfect, because this is exactly what you're looking for. But it's not just that. It's also that I don't have to worry about scaling, because, well, what happens with this is that it will scale automatically if you have more load or not, but it's the vendor, in this case Microsoft Azure, that will take care of that for us. And what I will pay is the execution time and the execution frequency that I will have. But you don't have to worry about anything else. If we're talking about functions in the Azure portal, so yes, I can create them straight away in the Azure portal. You don't even need to have any kind of IDE. Probably, well, not the best experience ever, but it is quite cool what you can do. What you can do with this. I can see some quick start templates, custom function templates. I can navigate to the function files. I can test the function straight away in the portal, and I can even still monitor my functions. And you see over there the last beat over there, where you're monitoring your functions. I can see the executions, how much time do they took, and what is the result code of that. So I can see, oh, a 400. Oh my God, what's the problem with this? I just need to figure it out. If you have errors, etc., you can always figure it out from here. So exploring input and output binding times. So first of all, what is a binding? So a binding is a declarative way for me to connect data from my code. To make it easier to integrate with data streams with that function. And the great way is that, okay, we have input bindings, which is bindings that we're going to basically bring data inside the function. But because there are bindings, and this belongs to the Azure Functions framework, I just don't need to do this. It's usually with what we call the plumbing code, that I don't have to worry about building this or taking care of this. This is literally something that just exists. It is just there, and I just need to connect my bindings, my data to the bindings, and bam, I get the data. And this also can be a trigger. Okay, and we're going to talk about triggers in just a moment, but I can have these bindings also with triggers. I can also have an output binding, which is basically a data destination. So in the end, my function will run, and then in the end, oh, this is the result, and I just want to write this to a series of destinations, so I can call this an output binding. Types of bindings that we support. So we support several types of binding, like blob storage accounts, Azure Service Bus queues, Azure Cosmos DB, Azure Event Hubs, external files, external tables, and an HTTP endpoint. So all of those are bindings that we can have. Then, now that we talk and we cover bindings, a great topic is also triggers. And triggers is defining how your Azure function will be invoked. And I have several types of triggers. I can have a timer trigger, an HTTP, blob, queue, Azure Cosmos DB, or an event hub. So let's just talk about like a timer trigger. So you can just put your function to be executed like every 10 minutes, for example. On an HTTP, well, you get an HTTP endpoint, then you can just send a post, a GET request, and there you go. Your function is going to start. But I can also have other amazing things, like I can have a blob trigger that it will be executed every time that that blob storage account container will get a new blob. So every time that some application user or whatever drops a new blob in that blob storage account, okay, basically our function is just going to start. So this, I can create amazing things with this, if you see, right? Because I can have, imagine a blob trigger, and imagine a blob trigger that is a photo. So every time that people drop a photo there, I grab that photo, and that photo is like one of those very high resolution photos from a DSLR or mirrorless, etc. And you can then take that picture from there, and then you can just create thumbnails, because you want to use thumbnails on your picture. So the function can do the creation of the thumbnails every time that someone drops basically a picture or a photo on the blob storage account. So that's a great idea to put this to execute. You also can have queues or Cosmos DB. Every time then a document changes on a Cosmos DB, every time that you have a message on a queue. So all of those are possibilities. So implementing function triggers. So I can have timer triggers, like I have a timestamp, a schedule, which is basically a cron expression, and you can put stuff like I said before, like every 10 minutes and things like that. I can have HTTP triggers, I can have blob triggers, or even webhooks, and all of this, okay, can be triggers to start our web app or Azure function. So much better yet, let's just do a demo with this, where I'm just going to create a function, and you're going to see, and I'm going to give a good overview about some of the triggers that we can have over there, and then I'm just going to do one of them. So I'm in the Azure portal, and the first thing that I need to do is I just need to create here a function app. I'm just going to create a function app, and this is where all my functions will then run. I'll just say, yeah, for the AZ videos, and I can just say AZ videos function. Let's see if it's available. It is available. I choose the runtime stack, .NET Core, 3.1. I choose here where I want to run things. Let's just imagine East US. And then on the next tab under hosting, I'm here and I'm able, okay, to choose, I need this associated storage account. What is the operating system that will be underlying this? So I'll just choose Windows, and what is the plan type? And under the plan types, I have 3 types of plans for my Azure functions, which is consumption, premium, and app service. I want the true serverless experience, so I will go for serverless. In terms of monitoring, like web apps, so this is important to have application insights, but because this is just a demonstration, I'm not going to bother into creating that. So I'm just going straight to review and create, and I'm just going to click create. Now, creating this, it is quite fast to create a new Azure function. So we can just wait here a second in order for this to be created. There you go. Done. We can then go to our resources, and there you go. This is our Azure function app. So now if I click here under functions, I choose the functions option, I can then add a new function. So I'll just add a new function. Then I can just say, what is your development environment? I'll just say, yeah, developing the portal, but of course you could, well, choose other options. And you have here, okay, hey, what is the template that you want to use? And they already have here some templates with some specific triggers, like an HTTP trigger, a timer, Azure Queue Storage, Service Bus, Event Hub, IoT Hub, you name it, okay? So there are several of them already built. I'll just go for a simple HTTP trigger, and they will ask me, what is the name for the function. So I will just say that, well, this function, it is going to be called demo function. And I'll just click add. So now this function is being added here. Just wait a second. There you go. We have the function. And now I can, under developer, so you can see here, code and test, and you can code your application straight away from the browser. So I can just come here and just in here be able to code this. And do I need to figure it out, the HTTP requests? I think no, there's nothing to do with that. That's an inbound trigger that we're going to have here. So a binding, and it's already done for you. So literally you don't have to worry about with that bit. So it is really cool, that part of Azure Functions. And because that plumbing code, like I said before, well, we just don't need to worry about that. So all of this will be done automatically for us. We just need to focus in this bit here, which is, what does my function do? And I can just do that, and I can even test and run my function in here. So this one here, I will just do an HTTP post. I will send like a demo here, a name like here, like Azure, for example. We just run this, and you will see that I will get a response, which is this yellow, and just replaces that bit. Basically, it's that thing over there that we have there, that name that gets, and then this HTTP trigger function executing successfully. So we can have this, and it's like super easy, as you see, to develop this using the Azure portal. So durable functions enables you to implement complex stateful functions in a serverless environment. With this, we mean to say is that when we have Azure Functions is stateless. They create stateless functions. But when we need to have a stateful workflow, well, durable functions are going to be the answer. And durable functions, in their essence, they are an extension for Azure Functions. But I can still run this in the cloud. I can still run this in an Azure container, or in the Docker container that I can then run on-prem, on other clouds, etc. And I have in my durable functions, I have three types. I have the client, I have the orchestrator, and I will have the activities. The client functions are the entry point for creating an instance of my durable functions orchestration. Then I will have the orchestrator, that is the function that describes how the actions are executed, the order in which they are run. So all of that part that can be run, that can be like C#, JavaScript. And then we have the activities, that they are functions that are the basic units of work in the durable function orchestration. We have here some examples of application patterns. I have a function chaining. In this pattern, the workflow executes the sequence of functions in a specific order. The output of the first function will be the input of the next function. I can also have the fun out, fun in. In this pattern, I can run multiple functions in parallel and then wait for all the functions to finish. Then I will also have the async HTTP API, the problem of coordinating state long-running operations without external clients. So the HTTP call can trigger the long-running action, then it can redirect the client to the status endpoint, and the client can learn when the operation is finished by pulling this endpoint. I can also have the monitor. So this pattern implements a recurring process in the workflow, possibly looking for a change in the state. I also have the human interaction. So this pattern combines automated process that also involve some human interaction. So a manual process within an automated process, is tricky because people aren't always available, and they are not highly available and responsive as a server. So human interaction can be incorporated using timeouts. And we can also have a compensation logic that runs if the human will fail to interact correctly in a specific response time, like 1 day, 2 days, something like that. So if we talk about designing a workflow on durable functions, so we can use them to orchestrate long-running workflow as a set of activities. In here, for example, we have here an example, which is this design approval process. So we have a project design that is submitted. Then there is an approval task allocated to the manager for reviewing. Then the project design proposal is rejected or it's approval by the human. But we can also have an escalation task allocated if that human fails to fulfill this in a specific time that is predefined, like let's imagine 2 days. So this is like quite interesting. In order to create Azure functions, I can also do that locally and even run them locally. For that, we need to have the Azure Functions core tools installed on our local machine, and we can generate files and folders that need for Azure functions. I can run them locally, and I can publish those functions to Azure just by using this Azure Functions core tools. It's a command line utility, and it's pretty impressive because you really don't need anything more. You just need this in order to initiate functions, run them locally, deploy them, etc. But let's just do a demo and let's just see how can we use the core tools in order to create functions locally. So, okay, I'm here on the Azure portal and let's create a local Azure Functions project. So for that, I'm just going to use here the Cloud Shell, because the Cloud Shell already has the tools installed and also has the Azure CLI already installed. So I'm just going to use this. I'm just going to create here just a folder, okay, called Low and Wizard. And what I'm going to do now is I'm just going to call the func init. Okay, so the func init command will initialize this directory as a functions project folder. After I do this, so I just need to say here, hey, let's just say I want a node project and I want this to be JavaScript. Okay, so it has been initializing this. So now I can just say func, okay, new, and now this will basically generate, okay, my my function. I just need to say here, what kind of trigger do you want? Let me just find here HTTP trigger. So let's just say 8. Okay, and now, yes, I just need to basically type here a name. Let's just say simple interest. Okay, and there you go. Now, I also have Visual Studio Code in the Cloud Shell, so I can just open my Visual Studio. And if I go here to basically to our code, you see here the simple interest and the index. So there you go. We have our function. For demo purposes, I already have here some code that I wrote. So I will have here some rate, some term, and basically this is already doing something. So this implementation basically looks for parameters named principal, rate, term in the query string of an HTTP request, and then returns a result using that simple calculation that we are doing, that we basically are doing here. It's nothing fancy, but yeah, just you guys get the idea. So let me just save this. Now let me close here the editor, and I can now just say, hey, I want to start my function. So func start, and basically my function is now starting. So now I just need to wait a little bit for this to start. Okay, so there you go. So this local URL is not published to the internet. It's only reachable from tools running inside the Cloud Shell. So I'm just going to use a command line utility called curl to interact with our. So for now, I'm going to stop my function, and I'm going to start my function again, but this time I'm going to run this with a series of commands to host silently in the background my function. Okay, so I'm just going to do this, and then I just need to write here the rest of the command. So now that I have this and it is running, I can now say curl, okay, and I can basically copy here, okay, the URL, okay, that I have here. Let's just copy this. Let's just put here past as plain text, okay, and now I'm just going to run this. Okay, so there you go. So curl, I just put in the URL, and then I just said -w and that one. Let me just do this, and we should be good to go. There you go. It is running, and you see there, oh, please supply principal rate term in the query string. So it seemed that it worked perfectly because we didn't provided that, right? Because we didn't provided that, so it just run perfectly. So now let's just provide something, right? So let's just say principal equals to, let's imagine like 5,000, for example, and the rate it will be equal to .35, and term, okay, equals to 36. And if we just do this now, okay, oops, sorry, I just spell this in here. So there you go. We did a very easy and short calculation. So we can now see that, yeah, it run perfectly. I can also now, okay, kill my function that is running on the background, okay, and I can also do code, okay, and I can do basically code the output, okay, that I have, and you can see here all the log, okay, of all the executions that that I have done, okay. So it is here, and you can still look at this. It's not because, you know, that, oh, I was running this in the background, that you're going to lose this. No, you still have access, okay, to all of this. And this is like just a very simple example on how cool those core tools they are, and how easy they are to touch and to just play around a little bit with them. Another option that I have to run and create functions locally is using Visual Studio. I can install this under Visual Studio. This is an extension for Visual Studio, and then yes, I can create a function app straight away in Visual Studio 2019, for example. It creates all the structure, asks me what kind of trigger do I want. It already creates a template for that trigger. So all the capabilities from the core tools, but in a visual experience and under a traditional IDE for most Microsoft developers. But let's just do a demo and let's see how can we create and test a simple Azure function locally with Visual Studio. So now let's take a look at how can I create a function but using Visual Studio 2019. So I can just say here, oh, let's create a new project, and I can search for functions, but, well, I already have them in here. I can just say AZ videos func demo. Imagine this would be the name. I'll just say I want to drop them in that folder. And now, okay, as you can see here, I can choose what is the function version that I want to do. I'll just go for v3, which is the more recent, of course. And then I can just say, for example, hey, I want an HTTP trigger function. And we'll just click create in order for this to create all our code in terms of our function. So we just need to wait here a second for this to be created, and there we go. There we go. We have here our function, and this is how easy it is. Now, just reloading some NuGet packages, etc. Then if you want to run this, you literally just need to basically click here, okay, where it says run the function. And if we say that we want to run our function, we just wait a second. There you go. This is the function you see here. Oh, Azure Functions core tools running in the background, of course. And there you go. So we have this. We have here our function. So I can just click in this one here. Let me just open a browser for this. Let me just minimize here the browser a little bit, and let's put this side by side. And if we hit this function here in the localhost API function 1, see, ta-da, there you go. Okay, it has been successfully, okay, just run. This is the time that it lasts to run, and we got this this URL, which is exactly what is supposed to, because it's what we have in here. Okay, so there you go. This is how easy it is to create a function using Visual Studio 2019, and of course, well, we could write here some other code that is more relevant for our business needs, of course. So after I create my functions locally, both with the core tools or with Visual Studio, I might want to deploy them to Azure. So I'm publishing a simple function to Azure. I can maybe just do this straight away from Visual Studio. So there is the publishing wizard. Then it requires me to have access to the function app, to the Azure subscription. But yeah, it can be done. It's very easy to be done. I can also do a continuous deploying, so I can just push my code into a repository, and then that repository will be already integrated with the function app. So I have the same capabilities that we have under the app service. And I can, by the last one, but not the least, I can also do the zip deployment. So Azure Functions can also be deployed from a zip file using the push deployment technique. I can do this using the Azure CLI or even by using the REST interface. The zip contains all the executable code of the function, and the tool, the zip deployment tool, copies those files into the www root folder of the function app. So that's also another option to do this. So, but let's just see how can I publish a simple function into Azure. So now that I have created the function, of course, I can also publish my function. So I'm just going to use this same function as we created before, and I can just right-click, select publish, and as you can see here, what's the target? I'll just say, yeah, it will be Azure, and I can just say here, oh, what's basically the underlying OS for this? It's going to be Windows, and basically now I just need to wait a little bit for this to reload. There you go, and you can find your Azure function app here, so this AZ videos func, and I can just say finish. And now let's just here, let's just remove this these dependencies. We don't need this for this demo, and I can then just publish. Now this just takes a few seconds to deploy, but yeah, there you go, it's going there. And if we wait now some more time, you will see that this will basically be shown in the Azure portal. So the name of this was not that very imaginative. It's just called function 1, but I'm sure we get the idea with this. So it's supposed to be already there. So if we go here to our function app, and if we go to functions, we should have a new function here. So now this is being loaded, and there you go. Okay, so there you go. We have here our function 1. So this is how easy it is to deploy the function. So creating a function that is triggered by a webhook. So a webhook is a user-defined HTTP callback. They are triggered by some events such as publishing code to a repository, updating a wiki page. And when an event occurs, the source site makes an HTTP request to the URL configured for the webhook. With Azure Functions, we can define logic in a function that can be run when a webhook message is received. So this is, well, why this is so interesting. And if you see, and if you can imagine the number of different scenarios that we can integrate with this. Imagine I want to monitor my company GitHub wiki pages that I have. Each time a wiki is updated, I want to be able to trigger a function that can process some of the details about that update, such as, oh, the updated date, the contributor name, and so on. So the first step, create a function app that contains a function that is triggered by a webhook, and then, okay, every time that someone changes something on the wiki, I will know that. So setting up a webhook for a GitHub repository. So yes, that's something that is quite interesting. So GitHub supports webhooks, and I can have webhooks that can be set up over there. So I just need to set up the webhook, create the payload URL, understand what kind of payload is coming in the post request, the content type that it come, and then I will just need to basically check that payload and take care of the payload and write my function to do, well, something that I want around that webhook. But let's just do a demo exactly on that. I'll set up a webhook for GitHub repository. So let's test an Azure function together with GitHub and webhooks. So first of all, I will need a new function app. So I'll just go here and just say function app. Okay, I'll click create, and now yeah, this AZ videos is good. I'll just say AZ func GitHub. So that's if this one is available. It is available. The runtime stack, well, let's choose Node.js this time, and let's go for East US. So here, let's just look at this. Yeah, it's all good. Monitoring, all good. So let's just click review and create for this, and let's just create our function app. So now that we have our function app being created, so let's just wait, and the next step will be just testing this function and see if it works. So now let's just wait a little bit so that we can have our function app created. There you go. It is created. Let's just go to our function app. You know, if we go to functions, and we will add here a new function. So yes, develop in the portal. Let's just go for an HTTP trigger, and I will just leave the name as the default name. And now let's just see. Here we go. Let's go to code and test, and there you go, our function here. If we test our function, and basically we just tweak this here. Let's put here John, and we click run. We should have a response, right? Let's just see our functions. Always the first time is always a cold start on this. Always takes a little bit more time, and there you go. Okay, it seems to be working perfectly fine. Now it's time to, and so now that I'm on my GitHub page, I'm just going to create here a new repository. Okay, I'll just say learn, okay, web hook test, and yeah, it is available. And I'll just create this this repository. So there you go. I'm creating a new repository. Okay, good. So the repository, it is created, and now, so what I'm going to do is I'm just going here under settings. Okay, and under settings I have an option here that says webhooks, and with this webhook I'll just add here a new webhook, and now I can say here, okay, what is the payload URL? So for doing this, I need to move to the Azure function again. I can click here to get, okay, the URL of my function, and I'll just use that one in here. Okay, so that one is basically this. I can just say here application JSON as the content type, and then I have to select, okay, which events would I like to trigger that this webhook will trigger. I will click select individual events, and now we have here a huge list of individual events. In my case, I'm just going to select the wiki okay, the wiki ones. So I'll just scroll down and select here the wiki ones, and I'll just add, okay, this webhook. So basically now every time that I kind of basically just change some stuff on the wiki pages, okay, so this will fire. And if you see here under the wiki, I can just say, hey, create a first page, and yeah, that's perfect. Like initial page, welcome to the learn webhook test wiki, and I can basically just save, okay, this page. Okay, so let's just do that. And now if I go to settings, and so if I go to settings, like I said, webhooks, and I should have here my webhook. And if I scroll down, you have here the recent deliveries, and yeah, you can see here 200, okay. And you see here the payload, everything that has been sent, okay, to that webhook. And of course, on the other side, well, that's just we could add something that can understand the payload here that we have here, and we could just kind of render this in an application, store this in a database, you name it. Okay, so the possibilities are unlimited here. Okay, it's really a large number of possibilities that I have with this. But you see how it is easy, okay, to basically create a webhook. So triggering an Azure function with a GitHub event. So the GitHub Golem event enables you to listen for wiki updates. When this event occurs and our Azure function is triggered, you can parse that payload and retrieve and process the data that has been sent by you. So that Golem event payload consists on a series of items like the page name, the title, the action, the name, the owner, so all of that. And yes, we can understand, and you see there basically the structure of that payload. That payload is then passed to the Azure function, and then, well, my function will just need to parse that. So let's just do a demo where I'm going to trigger an Azure function with that GitHub event. Okay, so now let's improve here our HTTP trigger 1. What I'm going to do is I'm just going to replace here the code with a code that it's aware of the Golem events that we have from GitHub. So what I'm going to do here is that, well, this is supposed to write something like pages, and then gets the page action is, and it will get the basically the action that we have done. I'll just save this, okay, and now I'm going switch to basically to GitHub, and I will go to settings. I'll just go to the webhooks, and I'm just going to basically push the event again. So I have the recent deliveries in here. I have this here. I can just say redeliver this one, and I say yes, redeliver this payload, and there you go. We have it redelivered, and let's just see what we have in the response. And see, now the response says page is home, action is added, and the event type is Golem. So a little bit different than what we had here on this one that just said that, oh, the HTTP trigger function executes successfully pass a name, which was basically that default one that is created by Azure. But no, you see, that's really understanding. Oh, it was the home, it was an edit, and basically the event type is Golem. So, right, pretty cool what I can do with this. So this is just basically understanding, hey, that's the payload, yes, and I will take care of that payload, and I will do something with that payload. So this is how we can integrate the Golem events with webhooks and Azure functions. So let's talk about how can we implement API management. So API management is a service that enables you to construct an API from a set of different microservices. Let's give an example. We have a web application, needs to interact with some customer data, some order management data, but we already have services in our company that, well, they interact with this. We also have a third-party logistic department that basically a partner that already has also a REST API. We can then also include things that come from the Microsoft Graph, for example. We can create an API management instance and then put all these different microservices, all of them together. This uses a serverless architecture, so this is based on, there's a consumption tier even for this, so you don't need to pay a full amount of money just for having the service running. And we have this as a fully managed cloud service. So there is, again, no need to manage virtual machines, to update this. So there's no need at all for doing all of that. And then we can also change the requests in flight. So I can understand in flight and I can do some tweaks from the responses and the requests in flight. So it's a pretty cool service. So let's just create a new API management, and then let's just see how can I add a function to my API management. Okay, so I'm in the Azure portal. Let's just create an API management. Create a resource, and I'll just say API management. There you go. This one serves, and I'll just click create. I need to select a resource group where I want to create this, and now I need to provide here a name. So AZ videos. Let's see if we can have this one available. It is available, and I'll just say here AZ Contoso and an administrator email like admin AZ, okay, contoso.com. And then on the pricing tiers, I could choose developer, basic, standard, premium, or consumption. In my case, yeah, I'm on the developer tier, and I don't want any application insights. And I also have scaling, which, well, basically I don't have because this is the development environment. So there's features like this that we don't have, and we could just review all of this. But for demo purposes, I just want to click review and create, and let's just click create. So now this will create our API management. If you create a premium or standard API management, it takes a while. So to be honest, basically, usually what we do is that we put this to create, and then we just wait for this to basically to create, but we do other stuff, and then we get a mail message saying that, hey, look, yeah, this has finished. So we don't need to wait, okay, for the process to finish. But for now, this one is the developer. So now let's just wait here a couple of seconds to see this up and running. And there we go. So now let's just go to our API management. And now under our API management, so I can just basically view here all the APIs that I have. I only have the Echo one, but I can add some more APIs. I can add a blank API using an open API file, using other representations, a logic app, an app service, which will basically be an API hosted in the app service, or I can click here to add a function app. And to add a function app, I can just basically search here. I have this function app. I can just select, and I have that function one that I can just add into this. So I'll just say the display name will be AZ video functions, and I'll just click okay, create, and this will be added, okay, as an API into my API management service. So now if I want, I can start to query this API through the API management endpoint and not the one in the function. So there you go. Okay, now I can see here my AZ videos func, and I have function one where I can do a get, or I can do a post to this specific function. So see how easy it is just to create here an API management and then interact with this by adding a function app into my API management. So what are the benefits of using the API manager? So usually when we talk about a microservices architecture, we always have a big challenge is that client apps are coupled to those microservices. If there's something wrong there, that app might, of course, struggle with that. So with this, we might want to decouple, right, those applications with those microservices. The API management will allow you to have that possibility. Also, each microservices may be present under different domain names, IP addresses. So again, hard then to manage all the tokens for all those different domain names. It will be hard to enforce consistent API rules and standards across all the services, even when sometimes some of them we don't even control. So the API management, yeah, it will help you because I can change the location and definition on the services in the back without affecting the client applications. Because the API management will be acting as an intermediary between the services and the client applications. And I can create policies to enforce consistency rules, and of course all the security requirements. I can also put them and configure them in my API management. Talking about API management authentication policies, so I can do the authentication with basic, so the authentication with a backend service using the basic authentication. I can also do with a client certificate or using managed identity, so the Azure managed identity service. I can create subscriptions in my API management, and I have 3 main subscription scopes, which is all the APIs. So I'll get all the APIs that I have in my API management. Single API, I will just scope this to a specific API that I have configured in the API management, or I can go for products. For products, it's basically a collection of 1 or more APIs that I have configured on my API management. So I can have, imagine 10 different APIs, and then I'll create a product that consists in 3 or 4 of those APIs. And I can just give you access to a specific product. So let's just do a demo and let's create subscriptions in Azure API management. So now that we have our API management fully created, we already added an API using a function, let's create subscriptions. So to create subscriptions, I just need to scroll down under API. I can find subscriptions, and as you can see here, I can just add a new subscription. I'll just call this demo subscription, and my display name, let's just say it will be demo subscription. And then the scope, I can say, oh, I just want specific APIs, so I can just click here and I can just say now only the AZ video funk, and I can then, for example, just save it, and I can create, as you can see here, a subscription that I will have this primary key, this secondary key, but it's only going to be specifically for that API, because that's what I wanted. I could have done products, for example, and I can create here a product, and I can create like all APIs, for example, and then I can just select here the APIs, and I can say, hey, this product will be those 2 APIs. So I can just say this. I can just create. I need to put here all APIs description, something like this. And then if I go now to subscriptions, I can then, under subscriptions, I can create a new subscription. Other subscription, and then I can select this, and now instead of the scope, I can say, oh no, it's a product, and then there you go, all APIs, the one that I created. I have to start it and unlimited, that there were 2 that already existed. So I can also create subscriptions like this, which is basically, it's based on a product and can be a collection of APIs. So this is how easy it is to do this. Really, really easy. What about policies? So policies in Azure API management are a powerful capability of the system that allows the publisher to change the behavior of the API through configuration. So policies are a collection of statements that are executed in a sequence on the request or on the response of an API. An example will be like converting XML to JSON and, for example, call rate limiting to restrict the amount of incoming calls from a developer. So all of these could be possibilities of policies that I can create. We have configurations divided into inbound, backend, outbound, and on error. So all of them are scopes that I can create these configurations. So, but better yet, let's just do a demo and let's see how I can set and edit an Azure API management policy. Policies and the way that we interact with our microservices, it's one of the great benefits of using API management. So in order to create policies that to change the behavior as we how we query those APIs, those microservices. So I can create policies, and to create policies, it's again not that hard. I just need to go to APIs. I select here, okay, what is the API that I need to interact with? And let's imagine it's this AZ videos function. And I can now select here if it's for all the operations or just a specific operation to do this. But imagine the following scenario. I have on the other side of this, so this API has a known performance issue that it doesn't handle more than 500 operations per 5 minutes, for example. So I can click here on the inbound process. So the front end gets the request. So this is the API management. And then it forwards this to the back end. But before it gets the back end, so here in the inbound, I can click and I can add a policy. And we have a series here of already built-in policies that I can just use. What I can use is I can do this, for example, rate call limit. And as you can see here, I can just say that, hey, look, I will, for example, accept, I don't know, like 100 calls per, let's just say 1 minute, okay? Per 1 minute. And then I can say the counter key will be the API subscription, or I could be like, oh, from a unique IP address or whatever. But I can just do this, and when you save this, basically right now I just said that, well, you can only do 100 calls per minute. So if we get on the API management more than 100 calls per minute, our API management can handle them, but it will not be forwarded to the they will not be forwarded, okay, to the service, because we know the service can't handle that. So it really doesn't matter to be sending requests and requests, and after requests that we know that it's not going to be responded. So we can do this. And of course, look, we can also do the same thing in outbound processing. I can add policies, and you see here, set some headers. I can call even other policies if I want. So there are like plenty of operations here and policies that I can define. But you see, it's not that hard, okay, to do this. If you want, you can click here on this icon, which is the code icon, and you can even see this by code. So you don't even need to use the interface that I use. You could just use this one here, which is basically XML. So you can also use this to define policies. So coming up tomorrow, it's going to be a day that we're going to cover identity and security. So basically, those are the two great topics. So implementing user authentication, authorization, then we're going to talk about security, key vault. And we still even have day 5, that it's going to be about monitoring, caching, event-based and message-based solutions. So it was great to be here today with all of you. And don't forget, we still have the self-paced learning resources on Microsoft Learn, so you can just check out this. There's great resources there about basically some of the topics that we covered in our virtual series. You can go to aka.ms/learn and you can find some amazing resources there. So I hope to see you all tomorrow for day 4.
Thank you for sharing your knowledge with us today. I hope our participants will really benefit from it. Also, as an additional resource, let me remind you that this series on developing solutions for Microsoft Azure will also be available for you to watch on demand at aka.ms/mpn/VTS. You can also download the list of upcoming VTSs and register for those in advance. So thank you all for being here with us today. We'll see you again tomorrow. Have a great day.